Hello, so today we will learn about Mosfet. Mosfet is an important analog device and it has two types, basically a depletion type MOSFET and a enhancement type MOSFET. So first of all we will learn about N-channel depletion type MOSFET. So as the name suggests, it already has a channel present between the two terminals, that is source and drain. We know that MOSFET is a four-terminal device which has source, gate, drain and body terminal. Body terminal is also known as substrate terminal. We have to note that the body terminal by convention has to be connected always to the most negative point in the supply. Now, in all those things, we need to remember the bias that we need to apply. We know that VDS is the drain to source voltage, which is always positive in the case of N-channel depletion type MOSFET. And VGS is the gate to source voltage, which can be positive or negative depending upon the mode you want to operate, that is in the depleting mode or in the enhancement mode, because depletion type MOSFET operates in both modes. So when the positive VDS applies, we have a drain current flowing between drain and source, because source supplies electrons to drain. This is an N channel, and N plus and N plus means the regions are heavily doped. The plus indicates the heavily doping between these source and drain, and the region between this is known as channel. So it has N channel and the substrate is P type. Now to turn on this device we need a threshold voltage which is negative, right? So when VGS is less than VT, the device is in cutoff. Cutoff means the device does not turn on and drain current will always be 0. So if the threshold voltage is negative, because for depletion type MOSFET threshold voltage is negative, this device will not turn on if VGS supplied to the device is less than threshold voltage, which is -1. So if you apply -2, -3, -4, -5, it will not turn on and the drain current will be 0. However, if VGS is greater than threshold voltage, means -1 voltage, if it is your threshold voltage, if VGS is greater than -1, then it can go in two of the regions. First one is linear, second one is saturation. So in linear, we have two conditions. First is almost satisfied, that is VGS is greater than VT. And second condition must be if you want to operate the device in linear region of operation, then VDS should be less than VGS minus VT. Then the device will operate in linear mode of operation. And the drain current in linear mode can be written as half mu n Cox W by L 2 VGS minus VTH VDS minus VDS का whole का square. Okay. For saturation region, this needs to be satisfied, that is VGS should be greater than VT, but the VDS, drain to source voltage, now has to be greater than or equal to VGS minus VT. As you can see here in this graph, this is known as drain characteristic, which is a plot between drain current and drain to source voltage. This voltage here is known as VGS minus VT over drive voltage. So the device will operate in the linear region before this voltage, and after it go into the saturation mode of operation. For saturation, what will be the drain current in the saturation region? The drain current in the saturation region is given by half mu n Cox W by L VGS minus VTH to the whole square, which can you also derived by putting the VDS value equals to VGS minus VTH. This is the basic symbol for N-channel depletion type MOSFET, where drain current is flowing between drain to source and threshold voltage is always negative. Thank you for watching. If you like this video, please subscribe to my channel.